A buffer overflow attack is one that takes advantage of a vulnerability inside of an application. Our applications have all kinds of storage areas in there to store variables and have a little buffer of memory set up for storing that particular information. A buffer overflow is one where you are storing information and overflowing that buffer. And when you overflow the buffer, you can cause different types of things to occur. If you're doing application development, you're writing your own programs, then you know that there's all types of checks that you should be putting inside of your applications to make sure that no one could overflow that buffer. But obviously, there are bad guys always looking for opportunities where you've forgotten to do that. The developers didn't put in those checks to make sure that someone couldn't overrun what they had in place for one of those buffers. A buffer flow is not an easy exploit to find. The bad guys can spend days, weeks, even months trying to find something in the application that would allow them to do a buffer overflow. And even then, once they've discovered a part of that application that they can take advantage of by overflowing one of those buffers, there's no guarantee that at that point it's even useful to them. Very often, doing a buffer overflow simply crashes the application. But if you can find the right way to do the buffer overflow with the right type of data, you may be able to cause that application to do something that was completely unexpected. And now if the bad guy can perform that buffer flow over and over in a very repeatable form, now they have a way to take advantage of that vulnerability. They can break out of that application and perhaps have direct access to the system, and now that particular system is owned by the bad guy. Here's a very simplified view of what a buffer overflow might look like. We have two variables in our application, a variable A and we have a variable B. The value that's currently in these applications, we're running this particular application that is nothing has been put into variable A, but you can see 1979, a number, has been added to variable B, and the hexadecimal representation of 1979 is 07 Bravo Bravo. Now, the key for the bad guy is they want to be able to find something in the application that will allow them to store information in variable A, but somehow overflow into a variable that's next to it. And what we'll do is simply add the variable. Let's choose the word excessive, excessive, and obviously the E is longer than the buffer that we have. And because our application is written poorly and allows this, we overflow into the next byte. So you can see the byte that's for E is the 65 instead of having that original number for our B variable. Now notice we've changed the first byte and the second byte of that. You can see now that instead of having that original number, it's now 25856. And now we may be able to take advantage of that by putting our own data into that particular variable. We may cause that application to perform whatever function we'd like. If it's an operating system application that's running and you find a buffer overflow for that, then you may have a way to break out and get the same control of a system that the operating system has. That's why you'll commonly see people performing operating system patches and updating their system because somebody has discovered a buffer overflow for that particular application. So by keeping your system up to date and making sure that everything is patched, you can be assured of avoiding any of these known buffer overflow problems yourself.